Now in this video let's discuss about the last two periodic properties, that is electronegativity and electropositivity. First let us see about electronegativity. Yes, what do you mean by electronegativity? It is the tendency of an atom in a molecule to attract shared pair of electrons towards it. So that is electronegativity. For example, you take the compound hydrogen fluoride, take H molecule, you can see fluorine is highly electronegative. So the bond electron pair, this is the bond electron pair, they will be more towards fluorine atom. So fluorine will take both the electrons close to it. So we say that fluorine is highly electronegative in nature. So electronegativity definition is the tendency of an atom in a molecule to attract the shared pair of electrons towards it. Now you know how does electronegativity vary? Electronegativity down the group decreases and across the period increases, which means group 1 elements are less electronegative in nature, whereas group 17, 16, they are highly electronegative in nature. And we know fluorine is the most electronegative element in the periodic table, and next to fluorine it is oxygen, which is the most electronegative element. Now next, you know what is the reason for this variation? I told you down the group electronegativity decreases because down the group the effective nuclear charge decreases, atomic size increases, and across the period you know effective nuclear charge increases, size decreases, so electronegativity increases. Now let's see what do you mean by electropositivity. Electropositivity. Electropositivity is the tendency of an atom to lose electron and form positive ion. And we know group 1 elements, they have more tendency, and group 2 elements also, to lose electrons and form positive ion. So we can say down the group size of the atom increases, electropositivity increases, metallic character increases, and across the period size of the atom decreases, electropositivity decreases. So we can say the relation between electronegativity and metallic and non-metallic character. Let's say about electronegativity, metallic and non-metallic character. We can say electronegativity and metallic character are inversely proportional. Means as metallic character increases, electronegativity decreases, and electronegativity and non-metallic character is directly proportional. That is, as non-metallic character increases, electronegativity will also increase. Okay. So this is about electronegativity and electropositivity. Now next let us see a term called diagonal relationship. Diagonal relationship. Now I am going to write few elements from second period. Second period we have in second period is this. Second period, you know, in second period we have the first element of each group, that is lithium, beryllium, boron, carbon, nitrogen, etc. So I am going to write from second period lithium, beryllium, boron, carbon, and I am going to write elements from third period who are lying just below this. Lithium, under lithium we have sodium, beryllium, magnesium, boron, aluminium, carbon, silicon. So these elements are in third period and these are in second period. We can say that the elements, or we can say behavior of lithium or properties of lithium is similar to magnesium. Then properties of beryllium is similar to aluminium and boron is similar to silicon. Now what is the reason for this? The reason is due to their diagonal relationship. That means similarity. What do you mean by diagonal relationship? The similarities of properties of elements present diagonally in the periodic table. So due to the diagonal relationship, they show similar properties. Lithium shows diagonal relationship with magnesium. Beryllium shows diagonal relationship with aluminium. Means the properties exhibited by beryllium is also exhibited by aluminium. Okay. Now next we have another term, that is anomalous properties of first element of each group. Anomalous properties of first element of each group. Now I told you the first element of each group. Group number 1, it is lithium, 2 beryllium, 13 boron, carbon, nitrogen, oxygen, fluorine. First element of each group shows anomalous properties. Anomalous properties means properties that are different from the elements of same group. Okay. Now if you take group 13, first element we have boron. Boron shows properties which are different from the properties exhibited by other elements. Now you can say that all the first elements in a group, they have similar properties, but when you compare the properties of the first element of the group with other elements, the properties are different. They are the anomalous properties. Now let us see what are the reason for this anomalous property of the first element of each group, or we can say the second period elements. First element of each group belong to second period element. That is our second period element. So let's see what are the reasons for this. The first reason is small size. You know, the first element has the smallest size in a group. Now the second reason is high electronegativity. High electronegativity. Okay. Now the third reason is maximum covalency is 4. What is the meaning of covalency? Covalency means the number of orbitals available for bonding. You take the first element of each group. First element of each group is in which period? Second period. And you know, for second period elements, the orbitals available are 2s and 2p. So total how many orbitals we have? Only 1 s orbital and 3 p orbitals. So total 4 orbitals are available for bond formation for that element. So we can say the maximum covalency of that second period element is 4. Means it can only form maximum 4 bonds with other elements. That is covalency. It cannot expand its covalency greater than 4. Okay. And whereas the elements of third period, fourth period, they can expand their covalency greater than 4, or they can show, or they can form more number of bonds greater than 4, because in third period we have d orbitals, but it is vacant. We know that the 3d orbital starts filling in fourth period, but third period we have the 3d orbital, but it is vacant. So what happens is these electrons in sp orbitals can jump to vacant d orbitals, and they can form bonds with other elements, which you will study in detail in the next chapter. Okay, so the third reason is maximum covalency for the second period element is 4, because only 4 orbitals are available for them to bond, whereas other elements of the same group can expand their covalency greater than 4. Now the next and the last reason for the anomalous property is the first element has the ability to form p pi multiple bonds to itself. That is, you have learned in organic chemistry, carbon can form double bond with carbon, then carbon can form triple bond with another carbon atom. So this is a bond. One bond is called pi bond, which is formed by p orbitals, which you will learn later. So this first element has the ability to form p pi multiple bond to itself, and also it can form multiple bond with second period elements also. For example, carbon can form multiple bond with oxygen, then carbon can form a triple bond with nitrogen. Okay, so this is p pi multiple bond, ability to form p pi multiple bond. So these are the four reasons which makes the first element of second period to show anomalous properties: small size, high electronegativity, maximum covalency 4, and the last is ability to form p pi multiple bonds. Now next let us see about the chemical reactivity of elements. Now, the chemical reactivity of an element can be observed from its ability to form oxide. So, here we are going to discuss about different types of oxides. So, different types of oxides. Now, we have basic oxides, the first type. Now, what do you mean by basic oxides? Basic oxides means the oxides when added to water, they form bases. There is group 1 elements. Group 1 elements and group 2 elements, they mainly form basic oxides. For example, you add calcium oxide to water, you get calcium hydroxide, which is a base. So, basic oxides are mainly formed by group 1 and group 2 elements, or we can say metals. Group 1 and group 2 elements are mainly metals. Metals form basic oxides. Now, next, so example for basic oxide, you can write as sodium oxide, then calcium oxide, etc. Now, next is acidic oxide. Acidic oxide. Acidic oxide means oxides when added to water, they form acids. Non-metals usually form acidic oxides. For example, sulfur dioxide, sulfur trioxide. When added to water, sulfur trioxide, if you add to water, you get sulfuric acid. So, example for acidic oxide is SO3, sulfur trioxide. Now, next type of oxide is amphoteric oxide. Amphoteric oxide. Now, amphoteric oxide means oxides which can act as an acid when they combine with base, or they act as a base when combined with acid. An example for amphoteric oxide is aluminium oxide. Formula of aluminium oxide is Al2O3. Now, the next type of oxide is neutral oxide. Neutral oxide means they have no acidic or basic properties. Example for neutral oxide is carbon monoxide, NO, nitric oxide, etc. So, these are the 4 types of oxides. Now, last, I have a table for you where you have the group number, valency and oxidation state of the group elements. So, I am going to write that. Here we have the group number in the first column, second column valency, and third column we have oxidation number, or you can also call this oxidation state. Now what do you mean by valency? Valency is the combining capacity of an atom. And what's the difference between valency and oxidation number? Both are same in magnitude, but when we say about oxidation number, it will be either positive or negative. It is a charge. Okay, whereas valency means we have only positive values. It's a number. So I am going to write the group number, valency and oxidation number. Group 1, valency is 1 and oxidation number shown is +1. Group 2, valency 2 +2. Group 3 to 12 you need not learn now. Now group 13 to 18. 13 valency is 3 and oxidation number is +3. Now when you see this valency and oxidation number, you know that plus shows electrons are lost, easily lost. Okay, now 14, group number 14, valency is 4, so +4. 15, it can show two valencies, 3 and 5, and the oxidation states are +3, +5. It can also show -3. Now next is 16, valency is 2 and oxidation number is -2. -2 shows that it's very easy to remove 2 electrons from group 16 element. Now 17, valency is 1, -1 and 18, valency 0, oxidation number 0. So this is the table of group with valency and oxidation number. Okay, now again in 11th standard you will learn in detail about group 1, 2, group number 13 and 14, the properties in detail. So there again you will come across this valency and oxidation state. So thank you.